Hi everyone, this is Mahdi from University of Pretoria and University of Neushabur. And today I'm going to talk about a dashboard which is created by the R software via the Shiny package. It can be used for tracking and modeling the COVID-19 data. And this is the link of the dashboard, Mahdi Salehi.shinyapps.io/COVID-19 dashboard. So let's go on and see the dashboard itself. As you can see, this dashboard is constituted of 5 main menus: dataset, demographic, time series visualization, dynamic growth models, and finally spatial analysis. But it is important to be noted that we have the results for both absolute counts and relative counts. But what is the benefit? Suppose that two regions have almost equal number of transmissions. But what about their population size? So in order to consider this issue for making a more fairly comparison between the countries and continents, we employed the frequency of cases in 1 million population of that region in the relative counts. But due to the lack of time, I just demonstrate some selected parts of the dashboard and skip the remaining items. Let's go on to the data set. This item actually displays the whole raw data that automatically comes from a repository in GitHub, this one, which gathers the reports of the Johns Hopkins University. Here you can use the search bar here to see the raw data of a country like this. After doing such a filtration, you can have this portion of the data in your own computer just by pressing this CSV button here. Moving on to the next module, which is demography. Here we can see the reports of the features, confirmed cases, deaths, and recoveries for the top 15 affected countries in the country submenu, and also for all of the continents in the continent submenu. But everything is the same for both of country and continent submenus. So let's start off with the continent. From now on, the design of the pages are almost the same. In each page, we have two subpages, absolute counts and relative counts, and the default is set to be first one, absolute counts. And for each subpage, we have the results for all three attributes: confirmed, deaths, and recovered persons. And for each window, you have two plus. The left one is for the new cases, and the right one is for the cumulative confirmed cases. But almost all of the plus in this dashboard are dynamic, and you can see the changes over the time. For instance, here you can drag this sign, this slider to the left side to a specific date. You can see the corresponding date here. And then by pressing this play icon, you can see the changes over the time, 2 days by 2 days as an animation. Well, let's go to the country. Here we have compared the top 15 affected countries by the coronavirus. You can see the confirmed cases, the death, and recovered for all of the top 15 countries. And also you can see the relative counts. And the rankings are completely different with the previous one. You can yourself go inside the dashboard and see the results. Let's move on to the next menu, which is time series visualization. In this menu, we observe the behavior of the regions over the time in terms of some time series plots. I'll go ahead with the country submenu, for instance. Here also we have both of absolute and relative counts. And for each of them, 3 tabs are prepared for 3 features. You can navigate between them to see the corresponding results. And the working with this panel is very straightforward. Just type some few letters of the country, and then you can see the time series plot for that country here. And also there is a facility here that you can compare the countries with each other over the time. For example, I add the India to this plot as well. But these plots are created by the Plotly package in R and so bring some facilities here with themselves. For example, we can simultaneously compare the curves with each other just by pressing this icon here. As you can see, we have both numbers as well as the corresponding date just below. The first portion of the plots are not needed, so we can skip it just by dragging the mouse like this, and then we can download this final plot just by pressing this camera mark that's here. Sometimes you need some more statistical information here, and it's very straightforward just by pressing the curve on the countries that you like. You will see some descriptive statistics as well as a plot which displays all three features together for comparing simultaneously. In the cumulative confirmed cases, we have the same structure, but there are some differences here, and that is you can switch between the logarithmic scale and linear scale of the y-axis just by pressing this button here. And also, once we click on this box, the fitted logistic growth model will be displayed, and you can see the prediction over the cumulative confirmed cases for the future 2 months. For example, let's try with Brazil and India. As you can see, the logistic growth model are fitted well on the observed data, and the R squared, which are just located below the names of the regions, confirm this fact since all of them are close to the 1. So we can trust to the predictions at least for a few days later. But what about the Gompertz model? We have another model here, which is called Gompertz growth model. That is also fitted well on the data associated with Brazil and India. And the corresponding R squares here are also close to the 1. But there is a difference between the logistic and Gompertz, as you know. The first one is a symmetric model, while the second one is an asymmetric model. There are some user inputs here that you can change them and see some other facilities. For example, the number of days to be forecasted is set to be for the next 2 months. You can increase it or decrease it just by pressing these arrows. If you don't like the gap between 2 consecutive days of the x-axis, just change this number here. And if you like to add a shadow representing a 95 confidence interval for our point predictions, just press this box. The same facilities are also provided for the logistic growth model as well. As you can see, we have added the 95 confidence interval to our point predictions. Well, let's skip the continent of the time series visualization and also the dynamic growth models, which was the fourth submenu. I directly demonstrate the last module, which is spatial analysis. Here we have the map, which shows the spread of COVID-19 over the world from the beginning of the pandemic up to the past 24 hours just by pressing this slider like this. We can press display mark here in order to see the animation and changes over the time from the beginning, which was the last week of January, up to the past 24 hours. Well, there are also some similar facilities for death and recovered of the absolute counts and also for the relative counts. But let me skip them and go to the Morons Index. In order to test the spatial autocorrelation of COVID-19 in a given continent, the interaction between countries has been estimated based on global Morons Index from the mid of March up to now, up to the past 24 hours. The Morons Index is a measure of spatial association which varies from -1 up to the +1, and its interpretation is the same as that of the Pearson coefficient of correlation. For computing such a coefficient, we need to have a symmetric weight matrix. There are two approaches to identify the weights: by 0-1 adjacent matrix, the first plot, and by geographical distance matrix, the second plot. For example, this plot is the p-value of Morons test with respect to the dates, to the corresponding dates, for the Africa continent. As it is observed, Moron coefficients based on adjacent weight matrix are almost significant at the significance level of 5%, the horizontal dashed line. And the values are around the interval of 0.1 up to 0.5, which indicates that there is a positive association among the confirmed cases of the African countries. This means that the increase of confirmed cases in a country implies the increase of cases in neighbor countries. On the other hand, in the second plot, evidence shows no significant spatial correlation based on the geographical distance approach, which indicates that the transmission region in a country is mostly because of having touching borders with an infectious center. Well, the initial version of this dashboard was released on the first week of April for public use, and from that time up to now, it's been continuously improving. It will be also supplied by some other tools like time series forecasting. But this dashboard was built based on a group work with collaboration of Father Smiley, my undergraduate student from University of Neyshabour in Iran, Professor Henriette Becker from Department of Statistics in the University of Pretoria in South Africa, Professor Mohammad Arashi, Department of Statistics, Shahid University of Technology in Iran, Dr. Johan Ferreira from Department of Statistics in the University of Pretoria from South Africa, and another undergraduate student, Francis Mutalla, from Department of Statistics and University of Pretoria in South Africa. This is once again the link of the dashboard, mahdisaleh.shinyapps.io/COVID-19 dashboard. Thank you so much for your attention.